interaction can be one-sided. The interaction here we will see one example for one-sided interaction. This is continually stirred tank heater. This is a heater. This is the heating element. Steam is passing through that. It supplies heat to this heater. So we have to control the temperature. For that, we are manipulating the steam. Another control loop is there. That is to control the level. A level transmitter is there. That level transmitter that gives its level to the level controller. So that regulates the outflow rate so that level can be controlled. Now two controls are there. One is level control. Another one is called temperature control. If you adjust the level control, suppose you are giving a set point change in level. Suppose you are giving a set point change in level means here steam flow rate is constant because temperature is now constant. That's why there is no change in steam flow rate. That time you are giving a set point change in level means as level increases, temperature will fall. We are giving only change in level, not in change in temperature. But temperature changes. Temperature changes. That's why the loop 1 interacts with loop 2. Loop 1 interacts with loop 2. But if you consider the loop 2, suppose you are changing the temperature set point change. You are giving a set point change to the temperature means the steam flow rate will be increased. Steam flow rate will be increased, but it will not affect the level. It will not affect the level. In the same way, you can see disturbance also. Some disturbance is entering into the system. For that, there is a change in level means definitely there will be a change in temperature. There will be a change in temperature. That's why the level interacts with the temperature. But because of disturbance, there may be some temperature change means it will not affect the level. So this is called one-side interaction, one-way interaction. Now let us see the interaction on both ways. It is a CSTR, continuously stirred tank reactor. In that reactor, a composition controller is there that will check the composition. Based on that, the feed flow rate is regulated. Feed flow rate is regulated. Feed flow rate is regulated based on the composition. Based on the composition, therefore the composition controller is there. Another one is temperature controller. The temperature T is measured. Based on that, the coolant, it is exothermic. That's why coolant flow rate is adjusted. Here coolant leaves here. Coolant leaves here. The product effluent leaves here. Effluent leaves here. Feed is entering here. Feed is entering here. In the CSTR, suppose there is because of disturbance, there is a change in temperature. Change in temperature means definitely there will be a change in composition. There will be a change in composition. Because of change in composition, this loop 2 interacts with the loop 1. In the same way, suppose there is a change in composition means definitely there will be a change in temperature. As composition changes, definitely the reaction inside will change. Because of that, there will be a change in temperature. This is an example for interaction in both ways. Loop 1 interacts with loop 2. Similarly, loop 2 interacts with the loop 1.